Today we're going to look at solving systems of equations by substitution. We've already dealt with solving systems of equations by graphing. For that, let's look at something like this one here. Here, there's two equations that have been graphed, and looking at them, we definitely have one solution. So, you could, in theory, find the answer to this problem by finding the systems of equations solution by graphing. But here it's going to be rather difficult. It's not on one of the crosshairs. It looks like it's about 3.5 for x and 2.5 for y, but it could be like 3.627 and 2.5974329. So rather than doing it that way, another option for solving systems of equation is by using the substitution method. Now there are 3 steps in solving via the substitution method. Step 1, you're going to solve one of the equations for one of the variables. These are typically 2 variable equations, or at least they will be for us right now. So you may have something like 3x plus 5y equals 17. So you're going to solve one of the equations for one variable. So in that 3x plus 5y equals 17, you may decide to solve for x, or you may decide to solve for y. But you're going to pick one of the variables and solve it so it looks something like y equals 2x plus 7. That would be an example equation that's solved for one of the 2 variables. You could also have something like x equals 2y plus 7. That's fine as well. It does not have to be solved for y. Second step, you're going to substitute that expression into the other equation and solve for the remaining variable. So since I have 2 equations, one of the other equations, or the other equation, is going to still be in standard form most likely. So maybe it's in the form 3x plus 4y equals 7. We've already decided that x equals 2y plus 7, so everywhere that I have an x in my second equation, I'm going to replace that with 2y plus 7. Once I've done that, I'm only going to have y's in my equation, and I can solve for y. Step number 3, once I have the y value, I'm going to substitute it back into one of the original equations and solve for x. I highly recommend checking your work at the end of this to make sure that you have correctly solved these. Okay, so let's try one so it'll make a little bit more sense. Example 1, we're solving this systems. We have negative 5x plus 2y equals 9 and x plus y equals 1. Both equations are equations that we could solve for x or y. But our second equation is going to be much, much easier because x and y don't have any coefficients. It does not matter which variable we solve for. Both methods will work. I'm going to go ahead and solve for x. So to do so, I'm going to subtract y from each side. Doing that, I'll be left with x equaling negative y plus 1. That y is positive, so when I subtract it from the other side, it's negative. The 1 is positive, and it's still going to stay positive. Since I've now solved for x, everywhere that I have an x in my original equation, or my second equation, I'm going to replace it with negative y plus 1. So in doing so, I'm going to have negative 5 times negative y plus 1 plus 2y equals 9. So again, everywhere that I had an x before, I've taken it out and replaced it with negative y plus 1, but the remainder of the equation stays the same. I still have my negative 5, I still have 2y, and I still have 9. The only difference is negative y plus 1 has replaced the x. Now, I simply have one variable. I just have y. I don't have any x's, so I can actually solve for this variable. I'm going to start out by distributing my negative 5 to each piece of my parentheses. So that's negative 5, a negative times a negative is a positive, so that's a positive 5y minus 5 plus 2y equals 9. Combine like terms, I've got 5y's and 2y's. So that gives me 7y, and I can add those together because they are on the same side. 7y minus 5 equals 9. To get rid of subtracting 5, I'm going to add 5 to each side. Leaving me with 7y equals 14. And dividing by both sides by 2, we end up with y equals 4. I'm sorry, y equals 2. So now I know part of my ordered pair. I know that the y value is 2. So I'm going to take that and substitute that back in for my y value so I can find x. So let's see, if y is 2, that's negative 5x plus 2 times 2 equals 9. 2 times 2 is 4, so negative 5x plus 4 equals 9. Subtract 4 from each side, leaving me with negative 5x equaling positive 5. Dividing both sides by negative 5 to get rid of the multiplying by negative 5, we'll get x equals negative 1. So our final ordered pair is negative 1, comma 2. Let's make sure that this actually works in both equations. So let's see. Negative 5 times negative 1 would be positive 5. 2 times 2 is 4. 5 plus 4 is 9, so it works there. Let's try the second equation. Negative 1 plus 2 is 1, and 1 equals 1, so it works in the second equation. Try example 2 on your own. I've taken away the need for step 1 because y is already solved, or we've already solved for one of your variables for the first equation. So you will not need to do step 1 for this particular problem. Take just a moment, pause your video, and see if you can come up with a solution. Did you get the answer to 1? If you did, give yourself a star. If you didn't, go back and see if you can figure out your mistake. You have 3 homework problems for tonight. Use your substitution method on each of them, and we'll discuss them tomorrow. Have a great evening.